Welcome to the Saurabh and Sagar Show. Today we are talking about something that is the backbone of every modern data-driven organization. That is data engineering.
Data engineering is an art of transforming, enriching, and extracting data from a variety of source systems, loading it into a target system which is designed for your business requirements.
It is one of those fields that operate behind the scene, yet it powers everything from AI and analytics to business intelligence and real-time applications.
It can be just data replication, it can be data governance, data integration, data matching, data quality. No matter what rules are required to convert that source data into target data, data engineers will do that for you.
In simple definition, data engineering is the practice of designing, building, and maintaining the infra and tools that enables collection of data, storage of data, processing of data, and retrieval of data. In this episode, we are going to break it all down. What data engineering is, the tools and technology driving it, best practices for building scalable data pipelines, and how cloud computing is shaping this field.
Data engineering job or a data engineer's job, I feel, is the most thankless job of all the roles that we have in an IT department. You don't see data engineers in the front, they're always in the back, but they are very important to the business requirements and getting the outcome fast, efficiently, and with the best quality required for your business.
Hello, everyone. Welcome to the Saurabh and Sagar Show. This is our season 2, and today we are going to talk about data engineering. And we are so fortunate to have our guest, Pam Lim, today on our show. Welcome, Pam.
Hey, thanks, Bo, for having me here today.
Welcome to the show.
Pam, your 5 years experience as a data engineer and architect. You started your career at KPMG, then you went to Slalom Build. That was all your consulting journey. And then obviously you went to the black side of the software role, which is the sales side or technical sales or pre-sales. A solution engineer now at Databricks. On your LinkedIn, you say that you are good at designing and implementing advanced data solutions. And when you look at your education background, an interesting one, which I would like to start with that question, is you did your BCom and then you did your master's in information technology. So Pam, again, welcome to our show, but let's start with that move of why you decided to move from commerce into IT.
Yeah, for sure. It's been a bit of a journey into, I guess, the tech industry, but I started out, as you've rightly pointed out, in commerce. Most of the subjects I did there were focused around accounting and finance. I eventually graduated with a degree in marketing and management as well. So my initial plan was to become a tax consultant. Before actually starting my first grad role as a tax consultant, I had an identity crisis and decided that that was not who I had to, that was not who I could become. And so I took a bit of a sabbatical to discover myself and discover my interests. And I ended up becoming a BA for an SAP consulting firm for about a year. So that's not on my LinkedIn, but just as a side quest, I would like to call it. I became a BA for an SAP consulting firm. And yeah, I just got to interact with developers and, just got to be a bit closer to things like coding and programming, and that really piqued my interest. So I, left that job after a year, and then I went back into uni, straight back into it to study a master's of IT. And since then, I've started my career in data engineering and consulting.
Your move from consulting to solution engineer. Now tell us about that. Was that something that was a decision that you made, or you just got an opportunity and then you said, hey, why not? I'll try it out.
Hey, I think it's always a bit of both, hey. I think like you pointed out, was in consulting for about 5 years and really felt that I, did put in the hard yards and, was able to experience full on end-to-end implementations, designing solutions from scratch. And I really was curious to see what it was like in the product world, what it was like to, take on a go-to-market strategy. How do you sell solutions to customers, what's important to customers in the market today. Yeah, that move was really just for me to understand and expand that skill set. I've always felt that, pre-sales and sales was a bit of a missing piece in my repertoire, and now's my chance to try it out.
I bet you would enjoy that. I thoroughly enjoy pre-sales role, so best of luck on that role.
Thank you.
You mentioned your first role in SAP. I remember in one of our conversation, you mentioned you were author in one of the books on SAP. Would you like to tell us something about that?
Yeah, sure. It's incredibly niche, so please don't expect too much from me. But it's actually a lease accounting book. It's actually on the lease accounting module for specifically IFRS 16 change. So it's an accounting standard related to lease accounting and I guess the consolidation of operating and finance leases, which is a very far cry from what I am doing today. But writing that book, I'm a co-author, so there are many other smart people who came together to write that book as well. But it really taught me how to engage with an audience, how to, meet your audience where they're at, how to speak to people about different problems that they're facing, how to become more technical, how to become more business focused whenever you need. So yeah, I am an author on Amazon, but don't count on me being a full-on SAP expert. Yeah, but still a very valuable experience, I think, that I gleaned from that time.
Data engineer, what is the role? What is a data engineer if someone comes and asks you?
Yeah, that's a great question. I think the data engineering discipline is focused on essentially turning raw data into consistent and reliable formats for business users, for data analysts, and for data scientists. So I think data engineers, if you think about that scale of data engineering, data analytics, and data science, I feel like data engineers are the ones who work the closest with source data and also focus on building systems to collect and store and process data at scale. So this could include building and maintaining data infrastructure, data pipelines, orchestration, data storage. And while I think data analysts and scientists focus on analyzing historical trends and visualization, experimentation, and predictive modeling, all those fancy things, data engineers often lay the groundwork for analysts and scientists. So I would say to a large extent, it's a lot of understanding what those people need, what data analysts and scientists requirements are, how data needs to be served to them at what cadence. So yeah, it's a multifaceted role, I think. But if someone were to come up to me and ask, that would be the answer I would give.
There's an interesting thing where the data engineers do all the hard work, but it's not a work which gives you fame. We do this boring job, which is still a critical job, and we don't get a fame. That's what I thought when I was doing a data engineering role.
Yeah, I can see that. I think it's very much data engineers are the unsung heroes of the data world. They're the ones scraping together the data pipelines, dealing with schema mismatches, conflicting taxonomies, and then you get an analyst saying, "Where's my data?" at the end of the day. So it's definitely not the most glamorous role, but it's a very rewarding one, I would say.
Data engineering is not only about like writing code or building and maintaining pipeline. It is also about designing your pipelines. So a lot of people forget that there's a lot of hard work goes into designing highly scalable modular data pipeline architecture. And that's the part of data engineering I love. And people think data engineering is all about coding or ETL and all these fancy tools. But before you build those tools, there's a lot of the journey of data engineering which goes through designing system, how you model or break your pipelines into different modules. I feel there's a lot of areas in data engineering which is still untold, like as you mentioned. The journey of data from data collection to processing of data and then storage of data and then retrieval of data. A lot of focus shift towards retrieval of data. That's where the business users are, the use cases are. And that's where these fancy tools like data science tools and machine learning goes. A lot of these backbone which serving those pipelines are is like not much appreciated.
Yeah, I couldn't have said that better myself. I think, data engineering is a huge misconception of it being, like you said, very code focused. People sort of, put their heads down, writing pipeline code. But behind that work, I think there's a lot of data architecture decision making that has to go into it. It's a small piece of a huge machine of trying to wrangle and tame organizations' data estates. So I think, like you've mentioned, it definitely is a team sport.
And we have gone through, in our experience at Slalom, at different client side, gone through that complex
sure.
journey of, design or code first, or iterative brainstorming. So it is very complex, especially when you are dealing with real world challenges at client side. What do you think is the biggest challenge engineers face today?
Yeah, so I think I may have alluded to that, but I think data silos in organizations, data sprawl across the data estate. So meaning that an organization might have many different disparate source systems, data stored in different locations, different formats and storage types. You have entirely different processes across business units of getting the data in. I feel like a lot of the challenges we faced with clients today was that a lot of the data is being held hostage really in on-premise systems and in fragmented systems and in proprietary formats with licensing agreements in place. I think all these tend to contribute to very significant bottlenecks and overheads in actually getting the data to unify in order to further along the analytics and science piece of it as well. Again, I think integration and processing overhead with format schema mismatches, governance and control on top of that also becomes a huge pain, can give rise to compliance issues. You've got things like data freshness issues as well, redundant copies of data being made across all these systems.
I'll add one point here. So out of everything you said, that's right. There's one area which causes a lot of pain to the data engineers on project is the diversity of tools we have, like the complex tooling, the ecosystem of different databases and the source systems. And there are so much options. We go through this complex assessment process and people have different likes about this tool is works best or whether to use ETL versus ELT. So yeah, I feel that's also one of the pain challenging area which we face day to day.
Yeah, I agree. I think that, like you've mentioned, I think we've been through, Saurabh, you and I have been through engagements where we've helped clients select tooling. And really, I would just call it decision paralysis because there's just so many tools out there that seemingly do the same thing. And it's a very challenging um, I guess, ecosystem to navigate what to actually select and what works best for, a particular use case, what works best for a particular culture, what works best for the skill set of the people who work at that organization. I think it's a challenging thing to navigate. And you've also, like you said, have people who are pretty much sometimes they're zealots when it comes to certain tooling. Others don't really have a direction. And, often I find that tends to come from top down as well. It tends to come from the attitude towards data, the attitude towards wanting to, try new things and take risks across the organization. And that will obviously vary depending on which sector you're in as well.
Which tool did you started your journey with?
Yeah, for creating pipelines, I think, DBT was something that I've used extensively, with the Snowflake environment as well. That was something that I used a lot when I first started out. Azure was also something that was quite baked into a lot of organizations. Actually, Azure Data Factory, I think, was the very first tool I got my hands on to transform data. It's a low code, no code tool offering from Microsoft, and it's sort of, taught me lessons around, how to process data in a smart way, how to do that incrementally, for example. How do you manage things like data freshness? How do you design, I guess, modeling and architecture to surface appropriate value in your system? Yeah, those are the couple of tools I think I first really got my hands dirty with as a data engineer.
How do you see the rise of serverless data processing impacting the way we do data processing? Like the tools we have, and like a lot of these cloud vendors, without naming any of the tools, have a native ecosystem where you could do things pure in serverless fashion.
I think serverless as an architecture, it helps to abstract away a lot of the infrastructure management. I feel like that was traditionally a required skill. So, the physical server processing, Spark cluster tuning, all that kind of a skill set. But I think with the rise of serverless, there's definitely less operational overhead. So that really means that data engineers can sharpen their focus on value creation, focus on actually creating, engaging with stakeholders and understanding what the business needs. I'm also finding that serverless processing tend to enable event-driven workflows. I see that replacing a lot of cron-based or batch pipelines. I feel like there is still definitely a time and place for reserved instances that sort of workloads because, they could be predictable if particular workloads are properly estimated and sized. But I think by and large, a lot of vendors have made the switch to serverless for their customers very attractive with their new cost models. I think from a data engineer perspective, again, I think as the skill set shift from managing clusters to becoming a little bit more cloud native. So understanding how the hyperscalers work today, the AWSs, the Azures, and the GCPs of the world, I think knowing those stacks is a very valuable skill set in the marketplace. I mean, also, like I've alluded to before, understanding how your data modeling and architecture can then surface that appropriate dollar value when you're actually on those hyperscalers.
It also removes that barrier to entry barrier. Like, we spend a lot of time building like non-differentiating, heavy lifting of all the infrastructure. Like if you have to deploy Airflow, you have to think about instance where the Airflow is deployed versus step function. I think some of the things which really helps in building your solutions faster and at a very low cost.
One thing which can be very biased is ETL versus ELT. So extract, transform, and load, or extract, load, and transform. What is your view on that, Pam?
Well, having sort of implemented both, I think ETL sort of speaks to definitely an older paradigm. I think it's from a place where maybe compute wasn't able to scale as quickly, or you weren't able to scale compute separate from storage. So ETL was a very popular, I guess, pattern to be adopted. But I think today ELT is sort of the way to go. You load your data in, you've got, you can almost scale your storage for very cheap. I'm sure you've heard of that lakehouse architecture. That's something that I think there are a lot of different flavors of that out in the market now. You just load your data into a low-cost storage. You have a format on top of it that allows asset compliance, and then you just transform your data from there. So my experience with ETL was that if, say, for example, the E breaks, so something in the T breaks, the L will break as well. But with ELT, it's much simpler to sometimes just dump the data and then start, navigating from there. So there's faster time to value. I think there's definitely pros and cons to both, but the ELT paradigm does definitely suit big data processing a lot more than ETL, I would say. What are your thoughts on that, Sagar?
From my experience, it really matters as to where the compute is bigger. That's where I would push the load. If the compute is bigger, assuming, and this is assuming that those two are two different infrastructures. So let's say you've got ELT having a separate infrastructure and your, let's say, warehouse or lakehouse having a separate infrastructure, then whichever has a better compute, I'll push the transformation on that side. That would be my kind of thinking. Like you said, most of the modern architectures have more compute on their warehouse or data lake architecture or infrastructure, and then naturally you just do extract and then transfer and load on those infrastructures.
I think there's also one area where the skill set of a company also drives some of these decision making. Where the ELT, we are going towards more analytics engineering, so load the data in the platform and more SQL based data engineering. While ETL, you can use sort of Glue or like more Spark, and whether you're talking about real-time streaming or you're talking about an ETL tool like a vendor-based ETL tool where extract, load, and data. So many companies have been very comfortable with ETL because they have a pool of skill sets and they have invested long-term in some of the ETL tools, and then it makes sense for them. But now if you're very new to the cloud ecosystem or building data platform, then you have a lot of options. Maybe building something, new pipelines in cloud. ELT is a more convenient architecture. You just start with loading. You don't have to go and find this giant ETL tool. There's another field in the data ecosystem, which is data modeling. So it would be unfair to talk about ELT, ETL without getting into the context of data modeling, which is not the topic for today. And we are not an expert of data modeling. But yeah, a lot of the challenges we are talking is addressed by how well you model your data on the cloud. Because remember, we always have three layers. If you say raw process model or like the medallion architecture, silver, gold. If you have modeled the data correctly, and then your data will go through the processing order, and then the quality of data will not suffer, and it won't be like garbage in and garbage out. So maybe some other day we'll talk about data modeling. Let's come back to data engineering.
Let's do a rapid fire. Pam, these are all stupid questions that I've come up with.
And the best part is the same question gonna ask to all the guests this season.
The important thing about these questions is you can't think about it, so don't think. It's whatever comes first to your mind. Okay, ready?
Ready?
Electric versus petrol car.
Electric.
This will be very easy for you with the way your career is going. Sales or consulting?
Sales. That's the only
Good,
right answer.
But I can't believe Pam saying sales.
good job, Pam. I would have said the same thing.
Uh,
Team or solo?
Team for sure.
Social skills or technical skills?
Social skills.
This, I think I'm going to miss this, or this is not going to be in favor of me. Sydney or Melbourne?
Melbourne, of course. Can't betray my
Finally, yeah,
hometown. It's 2-1
I need
today.
to get guests from Sydney. Tea or coffee?
Coffee.
Sleep or go to gym?
Sleep.
Reading a book or watching a movie?
Reading a book. Reading a book.
Use AI or use your brain?
Oh, this one depends. AI for menial tasks, using my
Oh,
brain for creative things.
no, but if you have to select one, what will you do?
But I had to select one. Using your brain is always, I think will help develop, certain pathways in your neural system somehow or rather, right? So that's always gonna benefit you in the long run.
Yeah, last one. Wisdom or knowledge?
Wisdom.
This was great.
let's move on to some of the best practices of data engineering and maybe building more scalable and reliable data pipeline.
Yeah, love for you both to chime in. The list is endless, I think, with building scalable and reliable data pipelines. But the first thing that comes to mind, I think, is governance and quality at the forefront. So in my opinion, taking a page out of the software developer's playbook. So doing test-driven development is always something that's going to save you a world of pain afterwards. So having automated validations, like enforcing your schema consistency if you need any anomaly detection or being able to flag missing values as part of building out your data pipelines. Lineage tracking is also something that's incredibly powerful if you can get in place as you build. And also, I think just being really proactive about reducing data duplication wherever possible. So, doing incremental processing instead of full refreshes every single time is something that's, going to create a very robust pattern for you. I think we've already mentioned some of this stuff, but having a modular architecture, decoupling your key components like ingestion, transformation, and orchestrations, each of these can scale independently where required. And then I think when building pipelines, two key concepts I like to think about is idempotency and determinism, making sure that the behavior of your pipelines can be as predictable as possible when you run them, regardless of what scenario. And a personal favorite of mine, I think, incorporating data ops as early as possible, incorporating CI/CD, pipeline testing, this sort of stuff helps you catch your errors early before you reach production. I think it also prevents the "it works on my machine" disaster, encouraging that environment consistency and lets you, promote to higher environments in a really safe way. So yeah, top of mind are these three, I would say.
And that's good. You covered all very well. Yeah, I think maybe this is one area subtopic is in data engineering we want to spend some time on because I think the audience would definitely look for the best practices in data engineering and what are the thoughts. So if one of the best practice, which is the modular design, I see, when you break your pipeline into modules, I think there's something called reusability. How important reusability is in your pipelines, because many times we make modular, it doesn't scale enough because you are creating a lot of modules, which is hard to maintain. So optimizing your modules by making modules more reusable.
Sometimes I think quality is sacrificed over speed, but I do think it's important to really understand what the ultimate goal is, like you said, right? What the business outcome is like, and to be willing to spend that time up front to do things well has a huge payoff afterwards. So I'll give you an example. I've been part of I've been part of one engagement where we were sort of split into different squads to take on different use cases. Everyone went out and wrote their own SCD type 2 logic. While they worked fine, ultimately, every one of these different use cases all had different order columns. And obviously that didn't play well when we were trying to join the data together, and that didn't scale well as well. And obviously the answer to that would have been to build out a shareable asset of, an SCD type 2 function maybe that would then be called by all these other different modules so that we could transform the data and load the data in a consistent way that was across that particular engagement. So yeah, back to your point, I think, spending that time to do things right up front, you can never go wrong with that.
Our story, and this is a fantastic story. So I'm not going to name the customer, a big bank in Australia. We did a real-time ETL, a web service for this bank, and they had a customer data. So let's say, sort of, you're a customer of the bank. You've got two accounts. They want to merge those two accounts together, and this needs to be online in real time. The payload was 10 pages. Okay, so for the 10 pages payload, we couldn't break that because as soon as we started breaking, the response time would be in seconds. So now, what do you want to do? Do you want to? So we couldn't even do anything reusable. So we just had one big pipeline, take the payload, do all the transformations, and then return back the results. And believe me, this now has become in that bank a pipeline which no one wants to touch because it's so huge that when you try to redeploy it, sometimes it just fails, and you just need to you just need to have luck to redeploy it. And everyone now blames me because that's how I started. And this was 15 years back. Everyone just started adding to that, and it's become a big job.
In the
But
Git
again,
blame, your name is there.
correct.
Technical debt.
But then even today, bank doesn't want to break that because they have the importance of that subsequent response. So they are okay not to break it or not to have reusable because the importance. So it goes back to what you as a customer or a business user wants to sacrifice and can't sacrifice on, right? What is important to you?
And I want to tell a story about a very nicely modular architecture, but which broke. And, just making it modular doesn't help. So I think one of the project I was working for, and it was pure AWS native serverless data pipeline. So step functions, Lambda function, glue. So the data would come in S3, would trigger a step function. It will process the data, and then it will dump the data into an S3. And then that would trigger a Lambda function. And then Lambda function, what it does is it unpack data from S3 and then call. So what used to happen was it was nicely decoupled. So all event-driven data in S3 to step function again back in S3, S3 invoking Lambda function, Lambda calling a REST API Lambda. So all nicely modular decoupled. But what used to happen is when so far still step function, it was good. But when Lambda was calling API, if the data volumes are large, it would call API, and that API was also deployed in Lambda, backed by Lambda. So what happens on AWS is there is a concurrency limit on AWS. So what happened was every 1,000 calls, it used to hit the concurrency limit, and pipeline used to suffer. Slow pipeline. So we build a CloudWatch dashboard where we say everything is processing nicely until it goes to the API call, and Lambda is maximized. So that's where I think we learned that the Lambda calling Lambda is an anti-pattern in the world of serverless. And even if modular, there are some part of architecture like incorrect architecture, anti-pattern can hugely mess up with your modular design. So, Pam, what do you think the impact of AI and how the evolving landscape of AI and Gen AI is impacting data engineering?
I think it's exciting, it's scary. I think when I first saw, OpenAI released ChatGPT, my first thought was, oh no, I'm gonna be out of a job in a few years. But I think, as we all know now, that's a bit overinflated, that rhetoric that data engineers are gonna be replaced by AI. But I suddenly think that AI will elevate the impact that data engineers can have. It's already changing data engineering by eliminating the very time-consuming and menial work that we do. So things like data cleansing and writing parser functions, that sort of thing, it's tasks that you can just throw to, I guess, Gen AI to do, or you can throw it to an LLM. I think, yeah, it's really interesting. I think from a machine learning perspective, even I saw that there was a draft paper floating around about how generative ML is already outperforming classical ML models. So generative AI can write ML models even better than humans, which, doesn't come as a surprise, but I think it is cannibalizing on certain, AI tasks itself. So from that perspective, I think prompt engineering is definitely something that will be essential for data engineers to craft prompts to guide LLMs to do tasks that I've mentioned before. The menial work of data cleansing and writing specific functions. So prompt engineering will help us guide LLMs to do these tasks more precisely and accurately. So we'll spend less time hopefully debugging the code that comes out from that. I also think that an interesting one is that as more organizations adopt AI into their ecosystem, my guess is that there will be a rise in the need for the skill set to develop AI optimized architectures. So maybe for data engineering, rethinking traditional pipelines and systems to think about how they can support real-time processing, automated workflows, file format optimization, and for us to maybe dip our toes into more feature engineering and model lifecycle support. I think there are a lot of emerging technologies like distributed model training frameworks and even edge computing, optimizing data pipelines for maybe edge GPUs to reduce latency. That's probably something that I can see coming out of the woodwork in the next 5 to 10 years. And the last one I had was, I think, AI FinOps. So understanding how serverless, auto scaling, and cloud resources impact the costs. How can we, as data engineers, eke the best performance out of these, price and efficiency out of AI tools that we're about to adopt? And how can we maximize business value from AI investments or align organizational goals with the actual spend? Because this stuff, I think, price doesn't seem to be something that's entirely predictable with integrating AI into ecosystems. And I think being able to provide governance and visibility over that will be a very valuable skill for data engineers to have.
Wow, you nailed it, Pam. I still feel even with the Gen AI, it will hugely complement the data engineering skills. You still want to make your pipelines operational, like ML ops, things like architecture and design will still exist, and you still need good data engineers to design better systems and more on the operationalize going to production.
Whether we like or don't like it, AI is going to change things and we need to embrace AI.
Human with Gen AI will definitely replace human without Gen AI.
Yeah,
That's
exactly.
good.
That's
That's a
Become a
good
human
quip.
with Gen AI. Yeah, so learn
Yeah.
through them.
Thanks, Pam, for coming to our show and talking about engineering, data engineers. What is it? What were some of the best practices? I really enjoyed listening to you and having this discussion with you. Thank you.
Likewise, I
Thank you,
really
Pam.
enjoyed catching up with the both of you. I hope to see you guys soon. Yeah.